Hello everybody, and welcome to another video. openSUSE Tumbleweed is arguably a valid alternative to Arch Linux as a true rolling distro with a rich set of packages. It prides itself with extensive testing of updates, BTRFS snapshotting out of the box, and a comparatively simple installation. However, it's a relative newcomer in the rolling release world, and perhaps less known as a result. Today, I'm going to take a closer look at a special flavor of Tumbleweed under heavy development called MicroOS. The system is immutable, like Fedora Silverblue, and yet rolling. More right after this. MicroOS already has the Podman container runtime configured, which is very convenient because we can make things more useful by installing the latest Distrobox wrapper. Then, we can run as many different Linux distro userlands we like. Podman is running as rootless, along with SE Linux enabled, so basic security is taken care of out of the box. Let's go. Here we have the MicroOS boot screen. So let's go straight to the installation. And it's loading the kernel. Let it come up. So this is the basic YaST installer for MicroOS. Rather simplified. All right, this is our license agreement and language and keyboard. Let's switch to cyan black theme. For change, to make things a little more legible, at least for me. I'm going to click Next here, since I agree to all the terms and conditions. So we have a choice of system role here. First off is MicroOS, which provides a minimal installation and a transactional update package. We got the container host, MicroOS desktop GNOME in beta. Also a KDE Plasma option desktop in alpha. And also the final two choices here are for remote attestation for security and against unauthorized changes to the image for your deployments. So we're going to ignore those for now and choose the GNOME beta desktop environment for this demonstration today. So I'm going to create my Steven account, as that's my name, and I'm going to also give myself a password. And I'm going to select this as a sudo for the system administrator password. All right, the installation settings are thus. Create a GPT for /dev/VDA. It's an EFI virtual machine. So two partitions, vfat boot EFI partition and a root BTRFS partition with the following subvolumes proposed to be created. That looks good. Ready for Snapper, which comes from openSUSE, by the way. And the software looks pretty good. Again, very basic, just enough to get us going for the containers. Here's the release notes, by the way. Yes, it is indeed Tumbleweed. But it's just the Tumbleweed release notes, nothing MicroOS specific. Looks like our time zone needs to be changed. We're not in UTC, but in the Pacific Los Angeles time zone, so I'm going to accept that. And scrolling down a bit here, we've got a network configuration. That seems okay. I've got DHCP enabled for my private local network. Using Network Manager, that's good. That's what I'm used to. Secure boot's enabled. Firewall will be disabled. That's okay. Secure shell service will be enabled. That's fine by me. SE Linux is in enforcing mode. That's good. And the target will be graphical mode, so GDM as a display manager, I assume. Good. So we're ready to install. It asks to confirm. And I agree. The target disk will be modified irrevocably. So it'll install, and we'll skip over the details here. It'll restart automatically when it's done. So I'll edit out this part of the video. And ready to boot the freshly installed system. There we go, GDM. I'm going to increase the text size. We'll use Xorg session today. We're not testing Wayland. Let's log in. So right now it's doing the following automatically on first boot. It's adding the FlatHub repository. Then it adds the Flatpak's Firefox, extension manager, and the text editor. Those three as Flatpaks automatically installed out of the box. No uninstalling like in Fedora Silverblue, etc. Very convenient. So let's go to the settings. Housekeeping first. If you like to indulge me, just hang tight while I make some configuration changes here, make things a little more legible for you guys and myself as well. I'll check on sharing here. Yes, remote login is turned on. Micro-1 is my DHCP server's assignment for the host name. It's a local 10 net. That's very secure for my testing that I have set up. For power, let me turn off the screen blanker since this is a demonstration. I'm going to also turn off the auto suspend so it doesn't go to sleep on us while I'm talking about the system. For displays, I like to fix the screen resolution to 1920 by 1080. I'm going to click apply. I'll keep the changes. And let's see what we have here. Accessibility. Again, I like to turn on large text for my demonstrations. And it makes it nice and readable, hopefully. And date and time, I like to make sure the network time protocol is enabled for network time sync. So I give my sudo password and administrative password again. Again, this is beta. So you're going to see a lot of warnings and other blemishes here. Again, it's under development. They'll eventually fix everything. We'll give them the benefit of the doubt today. All right, so this is what we have. openSUSE MicroOS, which is a form of Tumbleweed, rolling release. GNOME is already version 42.1. Cool. All right, let's move right along here. Let me finish up the housekeeping. Extension management is moved to GNOME extensions from FlatHub. GNOME extensions doesn't really work on MicroOS. It's not fully compatible, but they have Extension Manager, which is a separate package, Flatpak, already installed. So under Appearance, let me enable the dark mode for legacy apps, and also enable the maximize, minimize title bar buttons, as you can see here. Cool. So let's go and launch Firefox. That's Firefox version 101, I believe. Time.is shows that our time is exact, so NTP synchronization is working. Good. So moving along into the heart of the matter, let me show you the website for MicroOS. It's microos.opensuse.org. And let's do a quick browse here. So microservice OS built by the openSUSE community. It's designed to host container workloads with automated administration and patching, as they say here. So you get a quick, small environment for your containers. And yeah, they switched from Wicked to Network Manager. I can wholly support that. Remote attestation uses TPM, trusted computing, etc., etc. We'll skip that today. So the philosophy for MicroOS is that it should be predictable, not altered during runtime, because it's immutable, read-only file system. It's scalable, so it can be very predictable in your rollouts for every unit. It is reliable, so automated recovery from faulty updates. is included. So it uses the atomic update model with transactional updates. It uses BTRFS with snapshots. So it's very easy to rollback /etc should something happen to it, because that's where all the configuration files are stored, and it's read-write, not immutable. So it's flexible, so no new package format is needed. It uses standard openSUSE, tumbleweed RPMs. Yeah, as I mentioned earlier, it's an immutable OS. Rollback is simple. We'll demonstrate that today. Simplicity itself. Secure updates, so packages are verified. Tumbleweed, some say Tumbleweed rolling packages are very stable and reliable. For a rolling distro, it's very important. So you can do new installation without reboot. Update in atomic way possible. Yeah. Good. So it only needs 1 gig of physical RAM. I recommend at least 4. But it really doesn't need much because it's just a container OS or a host for containers. Minimal storage requirements. So yeah, perfect for experimentation. Again, this software is very beta. So you'll see a bunch of warnings in this video that you can safely ignore. Little reminder that this is not quite deployable in a production environment. So here are the package sources. So as you can see, openSUSE MicroOS is not selected because it's a immutable OS, but you've got the standard tumbleweed repositories that you can use to install your packages. Very rich selection right there. Okay, software. So you've got your standard GNOME software program. So for example, you can install anything you like from FlatHub that's available on FlatHub, such as LibreOffice. So you can see this is a Flatpak, and the only option is FlatHub, right? You don't have any other repositories, so it makes things a lot less confusing, I think, because Silverblue, for example, has a bunch of different repositories you can use to install packages. So let's install it and open it. So this installs in your user home directory. So you're not touching the immutable system when you install software. So here you go with the latest Flatpak for LibreOffice. Looks pretty good. So nothing surprising here. So that's how you install basic Flatpaks. Let's open up the terminal here. Let me fix the profile, make it more legible. Go here to Preferences, and let me minimize Firefox for a moment. Move this window over here. So we've got an unnamed profile. Let's rename it to Steven. It's my personal profile. There we go. I'm gonna make the custom font monospace 14. Make it nice and big for you guys. And we turn off the terminal bell so we don't have any annoyances. Also turn off the scroll bar and unlimit the scroll back to save a little bit more of a real estate. Okay, got a nice clean window. So let me F11 it to full screen. So we're already running the most recent stable kernel as of this video, which is 5.18.2. It's standard tumbleweed kernel, nothing unusual for MicroOS. Let me configure Snapper, make sure it's configured correctly. So sudo vim etc snapper configs root. So Snapper is pre-configured in this openSUSE distro. It's what they use as Snapper. That's an in-house utility. So I'm going to allow myself to work with the configuration file. So I'm going to add Steven and allow users. Let me check the cleanup configurations, the number cleanup. Hourly snapshots is turned off. cleanup is turned on. Okay. The limits for timeline cleanup, that's the basic Snapper defaults. I'll stick with those. Perfectly fine for today. But here you can play with how Snapper works. But that's outside the scope of this video. Okay. So next up, let's clear the terminal and let's do a Snapper ls. Okay, my font size is a little bit too big. As you can see, we're running the first root file system. So it's marked with an asterisk. It's Snapper number 1, snapshot number 1. Okay, so use space for the root snapshot is 2.13 gigs, which is the installed size. Very reasonable for modern distribution. Minimal RAM and system, well, for GNOME at least, and disk space usage. All right, so what's next? Let's move right along to the Distrobox GitHub site. So it's github.com, 89 Luca 89 slash Distrobox. And we'll hit enter. So this is the Distrobox GitHub site. It's a fantastic project. It's a wonderful wrapper for both Podman and Docker. As you can see here, use any Linux distribution inside your terminal. So it brings in the full userland as you need, including graphics and apps that you can export. So again, it uses Podman, which MicroOS has already configured as rootless. So yeah, so since Podman is already configured, we can just install containers that are tightly integrated with the host. So the home directory is shared, external USB devices, and graphical apps, and audio. So this opens up a wonderful world of possibilities. Let's go straight to the installation. So as you can see, Distrobox version 1.3 is available already for many, many distributions, including openSUSE Tumbleweed, which is a special version we're running today. So let me go here, look at the instructions. Okay, check the host distro's compatibility list for distro-specific instructions. So let me click that. And see if we can find Tumbleweed MicroOS. There it is, Tumbleweed MicroOS. So we'll just copy paste. We trust these guys, right? So it uses the transactional update kit, is already configured to run. So I'm going to switch over to the sudo first, of course. Sudo toolkit, or transactional update shell, and already created a snapshot, new snapshot. Every time you go into toolkit shell, you create a new snapshot in MicroOS. Very handy. So let's do the standard Tumbleweed zipper install. Zipper install Distrobox and also NeoFetch. We can install both here. So this would be the equivalent to Fedora Silverblue's RPM OS tree command. So this creates an overlay on the immutable image. Just adding 2 packages today. So we'll just exit. So new default snapshot is number 2. Remember, we originally had just a snapshot number 1. Now it's number 2. Transaction is completed. So every time we go into toolkit shell, it creates a new snapshot. So now we're on snapshot 3. We exit. Even if we don't do anything, it creates a new snapshot. So yeah, enter it again, and there's snapshot number 4. So there you go. So very safe and secure. So if something happens, you can always roll back. And I'll demonstrate that in a bit. So let's clear the terminal and let's do a Snapper ls. And as you can see, we're now currently on snapshot 4, denoted by the plus sign there. One day I'll do an in-depth Snapper video, but not today. To find time. Okay, so let's reboot. Because every time you do just like with RPM OS tree, every time you do a toolkit overlay and install packages, you have to reboot. And that's just the way it is with immutable operating systems. But we accept that, right? The key is you only have to do this once during the installation and you have everything you need. So let's run neofetch. So here you go. We're running GNOME 42.2, latest kernel, and running about 1 gig, which is not bad for GNOME 42. So here's the file system table. We've got a whole bunch of BTRFS subvolumes under root. And nothing unusual here. Standard Snapper configuration. We also have the overlay file system for Etsy, because in Etsy is where all our configuration changes happen. And it can't be immutable because otherwise we can't reconfigure the system, right? So if something's going to go wrong, probably that in Etsy. And I'll show how you can recover from an Etsy disaster momentarily. Please stay tuned. So let me open up a terminal here and let me, resize the terminal rather. Let me resize it. So Distrobox is installed. So we have the following commands: create, enter container, list containers, stop container, remove a container, and version, which we already know is 1.3, which is the latest as of today. So let's create our first Distrobox. Let's create -- image Ubuntu. And the tag shall be, with a colon, 22.04, which is the latest LTS release. And we'll call this Jammy for Jammy Jellyfish, right? So we can just name our container. So the image is not found because we don't have it yet. So we want to download or pull the image, right? We've got the registry option or the docker.io option. So I'll choose the docker.io option today. So the image has been pulled. So let's, that was easy enough, right? So let's pull another image. Let's clear the terminal and let's do Distrobox create -- image Arch Linux. And we'll use the latest tag here for latest image. And we'll name it Archie. And of course, the image is not found. So we'll pull the image from docker.io and let that happen. These containers are very small, so don't have much software installed to begin with, but that's where the fun begins, because you can install your own software inside the container and run it securely from the rest of the system. That's the whole point of containerization, right? Sharing the kernel. So anyway, Distrobox, enter, Jammy. Let's spin up our Ubuntu Jammy container. So it starts the container, installs the basic packages. So let's do the usual Ubuntu sudo apt update. We've got already 5 packages we can upgrade. So let's upgrade those, make sure we're up to date. Yeah. So you can see it's very, very fast because it shares the host machine's resources. So let's install neofetch, which pulls in a whole bunch of packages. Because again, it's a very simple image, right? Not much included for maximum flexibility. So neofetch shows that we're running the MicroOS or openSUSE tumbleweed kernel. And yeah, So we've got a full Ubuntu userland available to us. So let's open up a new terminal tab and let's enter our Arch Linux container with Distrobox -enter Archie. And it does the same thing as we did with Ubuntu just a moment ago. So it installs the basic packages. All right, so let's sudo pacman -syu. Looks like our latest image is indeed the latest. No updates available. So let's do the sudo pacman -S neofetch. Let's install the Arch Linux neofetch package. That goes very quickly. Arch Linux is it's wonderful. It's my favorite distribution. One of my favorites. So yes, we're running the same kernel as you can see here. And yeah, you've got a full Arch Linux userland here. You can build Arch ISO, by the way, with this container. I've done it. It's extremely fast, much faster than a VM. Container magic. So the third tab here, this is neofetch again with showing our MicroOS setup. As you can see, the containers, they don't really, it's very efficient with RAM. So you got full performance, CPU performance here, and very, very performant. So you can have all three running at the same time and not run out of RAM, even with a small 4 gig virtual machine. Amazing. So it's just limited to your imagination what you can do here with this setup. Okay, so let's exit from the Ubuntu container and exit from the Arch Linux container. So it looks like we've got a wonderfully functional MicroOS machine. So let's Distrobox list. So Jammy and Archie containers are still running. So we can shut them down by doing a Distrobox stop Jammy. Yes, we really want to stop Jammy. And there it goes. A couple warnings. Again, this beta software, we'll just go with it. We'll also stop Archie. So Jammy and Archie are now stopped. So if I do a Distrobox list again, you can see it's exited. So now all the resources for those two containers have been released from the host OS. All right, let's do a Snapper LS. So we're currently on snapshot 4. And as you can see with the asterisk. So let's take a look at that special directory, etc, where all our configuration items are for our Linux install. So you can see it's a fully standard /etc directory that we see from everything else. So let's destroy, let's do maliciously destroy. Don't do this in a production system, obviously, but let's destroy the system now. It's just a VM, a test VM for our demonstration. What we're going to do something dastardly deed. We're going to remove etc. We've got to do this as root, right? Yikes. Okay, I think we just destroyed our system. Let's make sure. So systemd is still in there. That's all right. Everything is gone. All our configurations are gone. So if we do a Snapper ls, we get a failure, fatal exception, because yeah, we don't have the configuration item anymore for the Snapper root. Yeah, this system is broken. If we do sudo reboot, sorry, you do not exist in the password database because the password database is gone. As expected, this system is truly destroyed. Let's see if we can recover using the Snapper system here. So let's reboot. And let me just try the default boot item here and see if we can just boot the system. Nope. Freezing execution. This VM is toast. So we need to fix it. So how we do that? Let me just force off the KVM and restart. So instead, let's start the bootloader from a read-only snapshot in reverse chronological order. All I have to do is find an earlier snapshot where we have a complete etc, right? The particular snapshot doesn't matter as long as it boots and has etc. So I just chose snapshot number 2. And sure enough, because it has etc, we can boot. It's read-only, right? So we need to test first before we do a rollback. So this is our read-only system. So etc is read-only, right? This is a read-only snapshot because Snapper does that by default. As you can see, our LibreOffice installation and our other applications are still installed. So it looks good. So I'm just going to roll back to this snapshot and restore my etc. Let me just do a neofetch here. As you can see, everything's still up to date. And Distrobox is still installed. Neofetch and Distrobox are still installed. We still have our containers ready to go if we need them. So this is a valid snapshot. Let's make this golden by doing a snapper rollback. Or first the snapper ls here. You can see we've got version 4 as the last booted snapshot. But yeah, let's just let's do a snapper rollback with a sudo first. Sudo snapper rollback. And there we go. Snapshot 2. The ambit is transactional because it's a transactional system with toolkit. Okay. That's what we booted from because we've got a valid etc. Okay, snapper ls. So the snapshot number 2 went from an asterisk, from a minus sign or hyphen to an asterisk. So that's the default snapshot that we're going to boot to when we reboot. So let's test this theory. So that's the default boot item in the menu. Okay, we're right into the GDM login screen. KVMs are so fast. Kernel virtual machines, it's incredible. Much faster than Oracle VirtualBox in my opinion, or VMware. Okay, so we are back in business. Let's do a snapper ls. So again, snapshot 2 is our default snapshot. And we can go to, roll forward or backward as we see fit, because we got a bunch of other snapshots to choose from. But we're back in business, right? Let's do a neofetch here. All right, everything is functional. RAM usage isn't even that bad for GNOME 42.2. So there you go. I've merely scratched the surface of what's possible with the MicroOS and Distrobox combo, and I encourage you to explore further. For example, you can build, install, and export graphical apps from inside a container to the host environment, which opens up a world of possibilities. Thanks so much for joining me today. I hope you had a lot of fun. If so, please like, share, and comment to make this channel more visible, and subscribe if you haven't already. Until next time, take care.